Hi everyone, my name is Heitor Matos, OEM Business Development Manager at Atlas Copco, and today I will teach you how to use the Atlas Copco Air Motor Selection tool. It's a quick overview, and before we go for the selection tool, it's important to know what information we have to provide in order to the selection tool pick the right motor for your application. So the information that we have to provide is 5 informations: is speed, torque, direction, integration details, and accessories. Two most important informations here is the speed and torque. And when we talk about the speed and torque, we talk about the working point condition, or where the speed is under load condition and the torque is the running torque. For those that are familiar with the applications using air motors, you know that we have different types of torque to spec the motor. So basically we have like a stall torque, running torque, and starting torque. So the torque that I mentioned here is the running torque. Okay, as this said, we can go to the online tool through this website, and we can go for some examples, but keep in mind that is online tools is only mentioned about our motors, the standard motors that we have in our portfolio. If for some reason the motor that you try to spec is not there, obviously we can build some special motor or customized motors depending on the applications. Alright, so here's the tool that we're talking about, the online selection tool. Just a quick overview about some of the features of this online tool. So first, it's like you can pick the system that you're going to use, if it's a matrix or imperial, depends with the country or you feel more comfortable to use. So also the language, you have like a selection help section here. If you need some help to understand how this works or calculation, you can just click here. But most important is like, as you mentioned in the previous slide, you have the working point. So with the working point, we have to provide the speed and torque, and we provide these two informations. This software starts to make like some calculations and spec the motor for your application. As you see, you have the picture of the motor. Soon that you start to select it, you have the dimensional drawing. You can just click here and print it out. You have the 3D drawings. You can print this window. You can recommend it like silencers, information for the motor that you have spec here. One other thing is like you can allow the tool to do this calculation for you and pick the right motor, or you can select from our catalog. So if you click here in the catalog, you have all the motors available in our portfolio, right? So just get back here. And also another important information is the performance of the motor. Here, as you see, like is the version of the motor. In red is the torque information. Green will be the power. Blue will be the air consumption in liter per second, or CFM if you change the units. And here is the speed. Here you see like all the important data for the motor, and the last is the product number. So if you decide to order the motor, you can order through this part number or through the model that the number have right here. We go in details about some of the options that we offer as soon that we're running some examples here, but important to mention here is like we have LZBs, LZLs, TZBs, and PZBs, which is the models of the air motors that we currently have in our portfolio. If you're not familiar with these names, I'm strongly recommended that you go to Atlas Copco YouTube channel and looking for the OEM webinar. So we explain in details what's the difference about the technology and different types of air motor. Right? So let's go for some examples. Here we go with example number 1. Well, this is a real case for a customer. They have a rotary fixture, and essentially what the customer needs is they have to rotate and position a bike frame. They want the speed to be close to 5 RPM, and the torque is something between 20 to 30 Newton meter, and they will control the rotation with the foot pedal, and they need the rotary to move and forward and reverse, which means basically it's reversible air motor. Main question is which motor should the customer use for this application. All right, for the first example, we have the torque that the customer mentioned, something around 20 to 30 Newton meter. So we just came here and let's say 25, just to be like in the middle point. And the speed he mentioned 5 RPM. So this is the first spec that the selection tool will gonna provide us. And as you see, the motor's LZB model. So it just can come here and see what options we have for the LZB. First option is like the direction of the rotation. That could be clockwise, counterclockwise, or reversible. As the customer mentioned, they need a reversible motor. They did not mention about like standard steel or stainless steel, which is essentially stainless steel we use for applications where they're concerned about corrosion, right? Which is not the case here. And the third option is with a brake or without a brake. So we pick the motor with a brake in this case because it's like a rotary fixture. So when they release the foot pedal, they expect the motor will stop in the right correct position or the most accurate position to positioning the bike frame. So for this reason, we pick the brake. In this case, we have the LZB33-LB-AR-26-11, which is the correct motor for the application. Here's the power curve. Here's all the data and the part number for the motor. And here's the information that you can get from the selection tool. So again, if they need like 3D drawings to see if the motor is gonna fit on their fixture, so they just can extract all this information from here, right? It's pretty simple, pretty straightforward, and let's go to the example number 2. Here we go with example number 2. So this is another example, is a real example from a real applications that we had in the past with a customer. Customer approached us and mentioned that they have an issues with the corrosion on their air motor or their machine. We asked them about like some of the spec of the motor, like the torque and the speed. They don't know, so we just asked them to send some pictures of the application. So this is the pictures that a customer sent us, so we know that is a mixing or mixer application, and so they just open this box and get a picture from the air motor inside. And here is how the air motor looks like. As you see, there's a lot of corrosion on this part, and the design of this air motor is completely different from the one that we previously spec, right? So we keep asking customer a little bit more information, and specifically now, what's the brand and the model of this air motor? So they provide us the brand and the model, and we just cross over to the Atlas Copco. When we do this process, we find out that the current motor the customer use have IEC flange, torque from 1.7 Newton meter to 2.9 Newton meter, speed range from 1900 to 2500 RPM, and a minimum starting torque with a 2.5 Newton meter. So there's a new detail here that was not in the previous application, which is like the flange. Flange is how the motor is gonna be connected to the fixture of the machine. In this case, is the part that is you see a lot of this corrosion. This is the flange of the motor. And IEC means that it is European standard. If it's American, it's a NEMA standard. So in this case, the motor that we have that comes standard with the flange is the LZLs. So, and the LZLs obviously was designed to retrofit electric motor or even pneumatic motor with the flanges, right? So if you see any applications with the flange, just go directly to the LZL option, and it could be like a plug and play retrofit, right? So with this said, let's go back to the online tool and let's go and spec the motor. Okay, we are in the online tool now. So again, the torque that customers set to us is like something from 1.7 to 2.9 Newton meter. So let's gonna pick like a middle point here, 2.4, and the speed range from 1900 to 2500, so we can consider as a 2200 here. So the first motor that the selection tool spec was the LZB, but as we already discussed, the LZB is not the correct option because it's missing the flange, and the customer needs a motor with a flange, right? This is the motor that I'm currently using now. And the solutions that we offer in our portfolio is the LZL. So we just came here on the models of the motors that we want to choose and just leave the LZL mark. And one more comment, that a customer needs to replace that motors because they have an issue with corrosion, so they need a stainless steel version. And here's the motor that they need, is the LZL5-RL-P-IEC, which is use the IEC flange, which is the versions what I currently use and the current motor now. So it'll be like a plug and play retrofit for them. But again, if the customer use a different standard, let's say like a NEMA, you can just come here and change if it's the case, right? Here's all the information about the technical information about the performance of the motor, and the part number is right here.